I want to spend a little bit of time at the end talking about your midterm one last time. The more times we talk about it, the less problems we'll have on the day, I hope. But the last topic I want to do is implicit differentiation, finding the equation of a tangent line. So I have removed the section to do with inverse trig and log, and we'll do that after the midterm next week. So your homework is reduced, and the questions that you'll get in your online test 5 will not contain that. So that might make your workload a little bit less as well. So that was kind of half the reason I did that. So let's look at it. Suppose you wanted to find the equation to this implicit curve at the point 1, 2, and you want to find the equation of that tangent line, essentially. So first stage you would do, step 1, is you differentiate. Technically, you differentiate with respect to x, that's how we phrase it. Hopefully you would say, hey, this guy's a product rule, oh, and so is this guy a product rule. And the only easy one is that if you differentiate 6, you get 0. You agree? Now, this first one, I'll do it in red. It's going to be f dash g plus f of g dashed. And the second product, x times y, is also a product rule. So I'm going to call it f dash g plus f of g dashed. You know, it's totally okay to have 2 product rules in a question, right? Can have. Right, let's do this one. If you differentiate x squared, you get 2x, and you leave g alone. Plus, you leave the f alone, and you differentiate y squared, which gets you 2y dy by dx. So that's that one done. You do the green one now, which is this one. You do f dashed times g plus f times g dashed. And if you differentiate y, you get 1 times dy by dx. And if you differentiate 6, you get 0. So step 1 is you differentiate. You do it with respect to x. And step 2, quite a big step this. You have to solve for dy by dx. And it depends on the situation, but there's a lot of situations that are very similar to each other. This one's pretty common. There are 2 terms here that have dy by dx and 2 that do not. The things that have a dy by dx, I want them to be on the left, and the things that don't, I want them to disappear. So I'm going to subtract 2xy from both sides, 2xy squared, and I'm going to subtract a y from both sides. And I'm going to leave this guy here alone. So that's x squared 2y dy by dx, and I'm leaving this guy alone, which is x dy by dx. That is a very, very common step, isn't it? It happens a lot of questions. The next couple of lines are pretty much standard. They happen almost every situation. What do we do in our next line of working?
You factor out the dy dx.
In this case, you get 2yx squared plus x, and nothing really happens over here. And the final step, at least to finding the derivative, is this guy, right? And that's pretty much happens every time as well, doesn't it? And how do we find dy by dx? What do I do to both sides?
You divide by the stuff in the parentheses.
Yeah, I just call it the ugly stuff normally because I don't want to have to repeat everything, right? There we go. And if we were doing it with style points, you might have step 3, just style points. Well, I'm looking at this guy, and I can see I can pull out a y. I could even pull out a negative y if I felt like it. Negative 2xy, take away 1. And on the bottom, it looks like I can pull out an x. And if I pull out an x, I get 2xy plus 1, don't I? Check that. 2xy plus 1, right? So far, so good. Is there any cancelling here? Because sometimes you do and sometimes you don't. And I want you to look out really carefully, because I'm actually telling you the answer is yes. It might not be obvious, but based on what's in front of me, you can cancel some things. If you take this guy, which is nothing but positives, and you take this guy, which is the same two things, but nothing but negatives, you are allowed to cancel them. What do you think gets left behind?
-1.
And so, guess what? Did you see that style points did actually help? You see how simple that derivative is? So just a minus y over x. I think that's kind of cool. Don't expect step 3 very often. Most of the time, you can't do much. Now, since this question is not find the derivative, if it was, we'd be finished, but find the equation of the tangent line at this point, we have another step to do. Step 4 is that we use the point slope equation to get the equation of that line. Now, the point that we're being asked to do has that coordinates. The derivative is negative y over x, which in this case is negative 2 over 1, which is negative 2. That means the slope of the tangent line is negative 2. The point has coordinates 1, 2, so that's x1, and that guy is y1. You put it all together, and you're done. Y take away 2 is negative 2x take away 1. So y take away 2 is negative 2x add 2. And that gives me y equals negative 2x add 4. And we're finished. That is the equation of the tangent line. Any questions about that process? Does it seem reasonable? As a kind of flow to it. While I'm doing what I'm doing here, could you do your attendance, your last name? That way I'm not wasting your time too much. No, I still can't do it. Okay. I'm trying to see if I can find some software that will draw it. I think there's one out there. But it isn't really, no, that's not doing that. Okay, don't have it. I was hoping that I could find some software where we could draw this and prove it. So can you pretend that it looked like that? And we have just found the slope of the tangent line there. And it would look like that. I'll probably have a little look once this class is over with. And if I can find some software that actually can draw implicit, then I'll put it in that module that you'll be able to use during your midterm in case you want to draw something as a check. Right.
Can't Desmos graph the original equation and then that one?
It can do this one. It's this one here I'm having problems with. I tried to make it draw that. Are you saying that it does draw implicit? That'd be
It
nice.
worked. It worked for that one for me.
Oh, so maybe I just typed it in wrong. Let me do it again then. Okay. So I did x squared, y squared. Oh, I may have to go to the end. Okay, xy equals 6. Oh, we are cool, guys. I should have just kept on going. Desmos, in fact, does it. So let me show you the real graph and what it looks like. Right. Are you looking at a picture of Desmos right now? Okay. That guy is the one that I just typed in a few moments ago, right? The parametric. And the straight line that we have is y equals negative 2x plus 4. Now, at that point there, can you see the coordinates 1, 2? Do you see the implicit curve? And that guy, aren't they a tangent line at the point 1, 2? Right, there's lots of other pieces of the shape, but that don't matter. At this point 1, 2, on this red curve here, haven't we got a perfect fit, a nice tangent line? If I had made a mistake and I did that, can you see at the point 1, 2, that line ain't tangent line to anybody, right? And so I could check it. So that's one very quick way that you can test that you've done that question and got the right answer. Let's return now and do 2 more examples because that's all I have time for. Give me a few seconds. These questions are right at the end of the homework. So I believe is it 13 onwards? Yeah. Okay. They're pretty ugly. I'm going to do 15 and then I'll do a trig one after that. So this is x to the 2/3 power plus y to the 2/3 power equals 4. And we're interested in finding the equation of the tangent line at -3√3, 1. Okay, my steps are, let's differentiate. If you differentiate this guy, it's the power rule. Multiply by the power, reduce the power by 1. This one, multiply by the power, reduce the power by 1, and then remember to do a dy by dx. And if you differentiate 4, you get 0. This guy, the whole package is really ugly, and it's a pure algebra problem. So this is going to be 2/3 to the 3rd plus 2/3 y to the 1/3 dy by dx. Are you comfortable about negative powers becoming positive powers on the bottom? Next thing I'm going to do is subtract that guy from both sides. And to finish with, shouldn't I divide both sides by this fella? Great. Now, if you divide by 2/3, isn't it the same as multiplying by 3/2, right? So what we in fact end up doing here is, although I am really dividing, I converted it to the equivalent multiplication. And then style points does kick in. This cancels with this cancels with this. So I have a negative, a y to the 1/3 over an x to the 1/3. So far, so good. I mean, this is pretty ugly math, but it does get there. And I want style points. And that means I want to try, I guess, to make this look as pretty as I can. And I'm not sure this is a help or a hindrance. But isn't it the same thing as that? Both of those answers are correct. You might think, why didn't I start doing cube roots and things like that? Isn't the original question written as fractional powers? So isn't it okay for my answer to be written in fractional powers? So we now have the derivative, and it's going to be at that point. The x coordinate of that point is that fella. That's -3 times 3 to the power of half. That's -3 to the power of 3 halves. So I'm actually going to be doing this fella. Now the derivative is, oops, try again, put my bracket too early. The derivative is the y coordinate divided by the x coordinate. These two negatives cancel out, and I get 1 over a third of this gets you a half, and that becomes, well, 1 over the square root of 3. So there's the slope of the tangent line, 1 over the square root of 3. And then I do y take away y1 equals m brackets x take away x1. Y take away 1 equals m, well, m I should say, this guy. X take away that guy. And that guy I'm going to rewrite as this fella. So take away a negative gets you plus. This is that guy. This guy times this guy. The root 3's cancel out. It's maybe not the prettiest equation in the world, but it actually could have been a lot worse. So that question had fractional powers almost everywhere. And the job of trying to keep track of them would be the thing that you have to be careful about. I'll leave that one for a few moments because there's a lot in there. Final question for today, and then I've got a lot of information to give you. This is going to be version of 13. You got that guy and that guy. And we're interested in the equation of the tangent line at the origin. This is a product rule. So is this. On this side, it's going to be f dash g as f of g dashed. On this side here, product rule formula as well. If you differentiate this guy, you get 1 dy by dx, and then you leave the g alone. Plus, you leave this guy alone, and you differentiate e to the sine x, and you do get e to the sine x. What else do you get when you differentiate e to the sine x? Because it's a chain rule. You differentiate e to the sine x, you get e to the sine x times something. Think chain rule.
Cosine?
Yes. That's ugly, isn't it? Right. Differentiate this guy, you get 1, leave the g alone. Plus leave this guy alone, and if you differentiate a cosine, you get a negative sine times a dy by dx. So what do we have? We have this guy. I'll tidy it up, I think. So I've got e to the sine x dy by dx. And then I've got a y cosine x e to the sine x. That's the left-hand side. This one here is a cosine of y, and multiply this out, you get a negative x sine of y dy by dx. So we have finished the differentiation. What we need to do now is solve for dy by dx. I kind of like this term, so I'm going to leave it there. What do you think I'm going to do with this term here? I don't like where it is, so what's going to happen to it? How am I going to get rid of it?
Add it to the other side.
Okay. It's a pretty common thing to do. Now, I do like the cosine y where it is, but I don't like this term. Why don't I like it? Because it doesn't have a dy by dx. I want the things that have dy by dx to be here on the left, and I want the terms that don't have it to be on the right. So I'm going to subtract a y cosine x e to the sine x. Okay, if you pull out a dy by dx, which is very common, you get that. And finally, dy by dx, as almost every one of these questions ends up being, unless you're really, really lucky, ends up being an ugly fraction. Now we are interested in the equation of the tangent line at 0, 0. So I'm going to find that by plugging in x is 0 and y is 0 into here to find out what the slope would be. So it's going to be the cosine of 0, take away 0 times the cosine of 0 times e to the sine of 0. And on the bottom, it's going to be e to the power of sine 0 plus 0 times the sine of 0. Now, although that is really messy, most of it is 0. Wouldn't you agree 0 times this is 0? And wouldn't you agree 0 times sine 0 is 0? Cosine of 0 is the number 1, and e to the power of 0 is the number 1. So guess what? The slope is just 1. So that horrible implicit thing that generated this equally ugly derivative, at least at the point 0, 0, the slope is just 1. And we are almost done, because I have the coordinates of the point and I know the slope of the tangent line. So it's going to be this guy. The equation for finding the equation of a tangent line. So y take away nothing is 1 times x take away nothing. Wow, you can get much simpler than that guy. And if I went into Desmos and I did this fella, and then I did this fella, shouldn't I see a tangent line, this straight line, shouldn't it be a tangent line at the origin, right? So imagine whatever weird curve it is, when you went through the origin, it had a tangent line of y equals x. Any questions about that? Okay. I want to now spend what time we have got left telling you some changes to plans. And so it'll take me a few seconds to load up. There we go. Come on. There we go. Right, I'm ready to show you. I hope I've updated this. If not, I'll tell you what the changes are, then I'll update it. There is an alteration And here they are. The 2 time slots for your exam are now going to be 10 till 12 or 11 till 1. Now, the reason I have to shift them back in there from what they originally were is that I have some personal things I have to take care of that kind of sprung up on me, and I have to be somewhere by about 2 o'clock. So I have to tidy up and get ready to go. So if I'd known that earlier, I would have told you, but I didn't know until yesterday evening when I got a phone call and I had to go to a meeting and things. And TMI, you don't need to know, right? It's changed, and that's my problem. What you need to do now is figure out if they work for you. Hopefully one of those time slots do work for you. It can, and it certainly can be any variation of that. So you could turn up at 10:30, for instance, as long as you finish at 12:30. So I'm trusting you to be honest about your 2-hour time slot, which you shouldn't really need, right? The test should take a lot less, well, a reasonable amount of time less than that, right? So you shouldn't have any time issues. If those don't work for you, then you need to tell me about it. And I have an alternate time slot that you can use, which is 7 till 9 p.m. roughly, right? So if you can't, if none of those 2-hour slots work for you, 7 to 9 works for you. Hopefully one of those is it. So if you're going to be a 7 to 9 person, if you could just email me so that I know that, because you are going to have to use a different Zoom. You know, the thing you click to get into Zoom, try to think of what that name is. You're going to have to use a different one because it will have run out. So any questions? Vanessa, you got a question?
No question.
Right. Do those 2 time slots make any real difference to your life? Are you okay with them?
No.
No problems. Okay. I'm assuming the no means that there's no problems. I hope. Okay. Second piece I haven't told you, I don't think I have, is that I'll be taking Tuesday off, and I'm allowed to take 1 personal day a quarter. So I'm taking Tuesday off. And I was originally thinking of just flying down to Vegas, having a wild party, get drunk, start a flight, a fight, and then come back. But instead, I'm going to be very adult about it, and I'll just be grading your midterm. That way you won't have to wait for a week to get your results back. You should get them back, barring accidents at least, sometime round about the late evening of Tuesday. So if you keep your eye open for an email late evening on a Tuesday, you'll be able to see all your results. That's not just your midterm result, but your grade so far. That'll be pretty important because that's roughly the halfway point, right? So it gives you an idea of where you are halfway through the course. Right, so you won't see me until Wednesday, right? So Monday midterm, see me again on Wednesday.
Professor, I just had one question.
Go for
Will
it.
the exam be about the same length as the practice?
No, a lot shorter.
Okay, just making sure. I was like,
Yeah.
this is pretty
No,
long.
you couldn't do that in 2 hours if you tried. No,
Okay.
Yeah, I doubt it. But you're going to get 10 multiple choice questions, right? So my rule of thumb is a multiple choice question should take you 3 minutes or less, right? You should be able to find shortcuts because I don't see working, right? When you do multiple choice, you just say question 1 is A, question 2 is C. And if you think it's going to take you more than 3 minutes to do it, then you're doing it wrong. And Rachel told me telepathy that she's going to pick C when that happens. So when you don't know the answer, it's going to be C, right? Or B, if that's the letter that comes into your head. And trust me, that is much more efficient usage of your time, just guessing, than spending 20 minutes on something that shouldn't take 20. And then you'll have section 2 where you will be writing your working. So I won't be looking for working, don't want to see it for the first part. So you'll just write on your piece of paper, 1 is A, 2 is B, 3 is A, 4 is C, 10 is D, and you're good, right? If you don't know the answer, it's also C, right? Never leave it blank. You might get lucky, right? And section 2 is where all the working is going to happen, and it will be in chronological order. So the first question you're going to see in the section 2 part is going to be the bit that we did in week 1. And the last question you're going to see, and I guarantee you're going to get one, is going to be implicit differentiation. Now, if you think of what we've done, you can almost guess vaguely what the questions are. It shouldn't surprise you that you're going to get a product rule, a quotient rule, and a chain rule, and an implicit. Would you agree? It's kind of what we've been doing a lot, right? So those kind of, there's 4 questions straight off the bat. So you kind of know that they're going to have. And you're going to have to find derivatives using that h tends to 0, x tends to a stuff, right? Because we spent a fair amount of time on that, so you should expect that. And then all the other stuff is just continuity and finding limits and whatever. Half of that will appear and half of that won't, but you don't know which, so study for everything. And the multiple choice will be pretty much the same, right? You'll get questions, product rule, quotient rule, and so on. So do we have any other questions?
And will we have access to Desmos?
Yeah, Desmos will be there. What will, if you can hear me over the barking. Oh, we've had a visitor. I think it's my sister-in-law's just dropped in. And my dogs have known my sister-in-law for ages. Yet evidently she's a danger and she has to be pulled by barking at her a lot.
I'll get it. Hold on, there you go. Sorry.
What's she been doing?
Got it hooked on the edge with her collar.
Oh,
I thought she was so mad she was bragging.
okay. Oh,
I
we
have a
have,
question.
yes.
So the ones that we're looking at right now are still the correct ones. The 10 a.m. to 12 p.m. and the 11.
Oh, yeah. So I haven't updated them. You're right.
Wait, so these aren't the ones? The
Let's
time
see these.
slots?
No, I have updated them. You got me guessing the wrong thing. Yes, these are updated. These are the new time slots, Vanessa. 10 till 12 and 11 till 1. That is the new time slots. Okay.
Okay, awesome.
Right. Awesome. I was going to say something probably not that important, but it did come to me and I've tried to remember what it was. Yeah. Section 2, I want to see as much working as you possibly can. Make sure that I would advise you to do each question on a separate piece of paper. That way, if you make a mistake, you can crumple it and throw it and do a new one and it won't get all cluttered. Do them in the order that's easiest, not in the order that they're written. So if you're really, really good at implicit differentiation, maybe that should be the first question you do. And if you're really, really horrible at chain rules, make that the last question that you do, right? That would be my advice. Since you do them on a separate piece of paper, when you're finished, can't you put them in order for me before you take pictures and upload it?
Scan them, yeah.
Or scan them or whatever you're doing. Yeah. And that might mean half the paper isn't used. I think we can keep the lumber industry in America going by using as much paper as we can, right? So I'm trying to help your fellow workers in America by doing that. Right, is there any questions, any topics, anything you want me to go over? Otherwise,
I have a question.
Yes, go.
When we do these problems, like a lot of times, like we simplify everything,
Yeah.
but will we get points off if we don't simplify it, like as much as possible?
Yes,
but the answer
you
is
will.
still correct.
You will
Okay.
lose points. So style points is a big deal, right? So when you get to I've finished the derivative, don't leave it as big ugly mess times big ugly mess. Make it look like the original, factor the heck out of it, do the best you can to the best version as possible. But because I see working, if you put a plus 2x and then you forget and you write a minus 2x the next line, you won't lose a lot of points because that's just careless. Because I tend to look for the process. So if I know you're doing the process right, I'm quite forgiving about little silly mistakes. like pluses and minuses disappearing, if I know that, you know, you just made a mistake in the copying of it. But yeah, style points are important. You got to remember that some things are ugly and they stay ugly. So don't spend half an hour looking at some really horrible, then we get a really horrible one in the implicits. Don't 9 times out of 10 anyway, they're really ugly and they stay ugly. Normally those are ugly, but can some product rules actually come out quite nice if you're careful, right? Common factors, things cancel. So being more on the lookout for product rules, especially turning into something nicer. Oh, and I think I just remembered what my question was, or what I was going to tell you. The only thing that's going to exist on the day of the midterm will be the one module that has all the stuff for your midterm. So it'll have Desmos in there. It will have the link to the Zoom meeting there. It'll have the PDF that you'll have your test on so you can read it. And it will also have a place where you upload your working. And remember, I've got a little practice one for you to get used to doing it. If you want to do it by just scanning it and upload stuff, that's fine. But make sure you know how to do it, because it's not really helpful on the day of the test to say, oh, I didn't bother checking that software and now I realize I don't know how to use it. So find out right now how to use it. There's a lovely video there that tells you more than you need how to do it, right? How to use it and get it into a PDF form. So everything in WebAssign will disappear except the ebook. And the only thing you'll see, there won't be any videos to watch or anything else. The only thing you'll see is the midterm information, the things you need for your midterm. You are allowed to use calculators. You will be able to use Desmos, and you will be able to use any notes that you have written. You will not be able to phone a friend. So Rachel, you are not allowed to phone Jessica, right? I need to see you, so you'll have your video cam on. So Rachel's twin sister doesn't come beside her and tell her what to do. Or her son or daughter. I know she has children. You have 2 children, don't you, Rachel?
Oh, I have more than that.
Okay.
But I do, I was gonna ask a question. Oh, it's about 15.
Okay, so what we can do right now, you just hang about. Anybody who's got homework questions, things like that, you just hang about. If I've answered all the questions that you need for the midterm, your time is valuable, so I'll say bye-bye to you right now. Make sure that you've put your last name down. If you want to watch other people's homework questions, because it might be a problem you'll come across, feel free to stay. Otherwise, bye-bye. Okay, Rachel, what's your question?
you.
You're welcome. Bye-bye.
I have a quick question about the midterm.
Uh-huh.
Do you care if it's all in one scan or one upload, or do you want them all in separate
Oh, no.
uploads?
Glad you asked that. I love it in one upload.
One upload.
Just have it
okay.
in one big PDF with 6 pages in it, or whatever it is. That's
Okay.
exactly what I want.
Okay. Thank
Good
you.
question. Glad you asked that. Right. Let's get yours. What section is your question on, Rachel?
It's the, let's see, 3.5.
Okay,
And-
implicit. And
Yeah, and it's number 15. It's the one you just did.
number 15. Oh, I still
Yeah.
got the notes for that.
Oh, good.
Okay.
So,
15.
right.
That was this horrible mess, right?
Oh, yeah, and it's even worse when I did it. So
Ooh.
my question
Mhm.
is, at what point? Okay. So I came up with for the slope, the M, before I plugged in my points, cube root of y over, or I'm sorry, negative cube root of y over negative cube root of x.
Okay, that's fine.
Yeah.
That's correct.
Okay. So when you plugged in,
So
you just kept it as an exponent.
so you had negative, if I got this right, negative cube root of y over cube root of x.
Yes.
Okay, That is the same thing. Now, in this point here, what was the coordinates of this darn point? It was quite weird, wasn't it?
X
That
was
fell-
-3 square root of 3,
Yeah, and y was, I believe,
and
1.
y was 1.
Okay,
Mhm.
so let's make sure that you got the right value for m, because up to here, everything's good. Now,
Okay.
if you do negative the cube root of 1, that's basically -1. So that was the easy one. Now, if you do the cube root of this guy, it's very helpful if you call him 3 to the 3 halves, because the cube root of 3 to the 3 halves is the cube root cancels with 3, and you get 3 to the half, and therefore you would get that guy. And there's a negative going on here, wasn't there a negative? Yeah, there was a negative here.
Mhm.
So you get another negative, and those two negatives get you a plus. So that's the same thing that I got. It's just that when you've written it this way, you are trying to find the cube root of -3 square root of 3. And that is one ugly thing to calculate, right?
Yeah, and I got the right answer, but
Oh,
it was
cool.
huge. It was huge and awful. And
Well,
so I want to
when you
know
said
how.
the answer, what do you mean? Did you get a decimal or a number?
No, I put it in just like that. I was doing cube roots of -3 square root of 3. And
That's
so,
perfect.
yeah, well, I'm just kind of wondering how I would consolidate it. And so I'm looking.
Okay, so what I'm thinking of is a cube root is a 1/3 power. So this thing can be thought of as a 1/3 power. 3 times the square root of 3 can be thought of as 3 to the 3 halves. Now, the way I got that is that's a 3 to the 1, and that's a 3 to the half. If you multiply things together, you add their powers, and 1.5 is called 3 halves. Now, if you've got a fraction raised to a power, what you can do now is you can multiply them together, and they cancel, and now you've got that guy, and that guy ends up being him. So you now have -1 on the top and negative him on the bottom, and that's where the +1 square root of 3 came from.
Okay. That's
was-
what I needed to know.
Right, it was really, really ugly and probably a little unfair, but I can't help what WebAssign does sometimes.
Okay.
I wouldn't
Okay.
typically give you one as weird as that. You would probably get one where calculating M was reasonably straightforward.
Okay. Well, and I needed to know how to consolidate those exponents, and that's exactly what I needed. So,
Okay.
all right. Well, thank you.
You are welcome. Bye-bye if that's all. Anybody else got a question, homework or otherwise?
I've got a homework question.
Okay, what you got for me now?
It's less about getting the work
Uh-huh.
and more, there's one question on the chain rule
Uh-huh. Okay.
part of it.
Right. Let me go. What have you got a number for me?
Yeah, number 17.
Okay.
It's just, I did the practice another and I did it a few times and I'm pretty sure I have the right answer, but there's this symbol right next to the EZ and I don't know how to input that.
Oh, okay. Let me see what the answer is. And it looks like that's question 17, as you said. Right. I'm just checking WebAssign to see what it did, so I'll know what it's after.
There's like a little slash, but every time I try and make that slash, it'll give me a fraction.
When you say a little slash, are you trying to write down that?
No, the equation is f to the z or fz.
Oh, I've got you. It's e to the z, little funny slash z minus 5, right? That's what you were
Yes.
trying to do. Right.
Yes.
If you are trying to do that, that little slash is actually a fraction. So when
it
you,
is.
yeah, so you go E, and there's a button over here, isn't there, that looks like that? It's a little fraction button, and you hit it. And then in the top one, you'll put this guy, in the bottom one, you'll put that guy. So that's how you would type it in. Do you want me to show you on the screen?
Nope, I got it.
You've got it. Oh, you,
Yep, gave me a little check mark.
you did it as I was talking, right?
Yes.
Right, that works. Okay. Any other questions?